Hello guys, and welcome to chemistry class. And of course, in this class, we are going to be looking at atomic numbers, relative atomic masses, and relative molecular masses. We are going to be looking at what they are and of course, how we can easily find them. So in the previous class, we looked at ions, atoms, and molecules, and then we gave a very wonderful introduction to the particulate nature of matter. If you have not watched that video, please, you should quickly go back, pause this video now, then go and watch it. So let's pay some bills. Know that this video tutorial is brought to you by the O3Schools JAMB application. Right, O3Schools JAMB app is by far the best CBT practice app available for your success in your examination. So please do not sleep on this application, right? So it has all the past questions that you will ever need for all your subjects. It also has likely exam questions, and of course, what are other wonderful features that will make you want to download this app? Of course, it has different modes for practice. There's exam mode, there's practice mode, there's mock mode. That means if you do not even pay for mock exam, for JAMB mock exam, you can set mock exam for yourself, right? So on the app, and then you time yourself, the time you want to use, you time yourself for your first subject, and then you shoot. Of course, then it's very flexible. You can choose any mode you want, right? You can choose the random mode where questions from any angle can be thrown at you. Of course, there's also a wonderful feature such as the UTME challenge. UTME challenge is a challenge that brings all JAMB students together, and then they compete to win prizes on the app, which is done every Saturday. So of course, if you see the features in this app, you definitely want to download it. There's also a question search feature where you can look for questions by topic. So let's say, for example, after you are done with this topic, now you can go to the JAMB app, go to question search feature, search for atomic numbers or relative molecular mass, relative atomic masses, where questions have been asked from the topic. You will see all the questions from there, and you'll be able to attack them, thereby building your confidence in your preparation for your examination. There's nothing, absolutely nothing you can value more than confidence in your exam. When you get to the exam hall like this, you are fully loaded. There's fire in your brain. You just want to pour all the knowledge you have. Of course, this app will help you get to that point. So we are going to kickstart our topic quickly. We're not going to take long in this topic because we're trying to break them into modules so that you'll be able to comprehend them. All right. So what is atomic number? We'll start with atomic numbers. Said atomic number is also called what? The proton number. Atomic number or the proton number is the number of protons present in the nucleus of an atom. So atomic number or proton number is the number of protons present in the nucleus of an atom. If you saw the last video, the last episode on chemistry, of course, we touched a bit about atomic numbers. Of course, what's there to also know is that in a neutral atom, the number in a neutral atom is an atom that does not have a charge, that does not carry a charge on it, right? So in a neutral atom, the number of protons equals to the number of what? Of electrons. This is valid, right? So if this is valid, and we know that atomic number is the number of protons present in the nucleus of an atom, that means that in a neutral atom, atomic number is also equal to the what? To the number of electrons. Is that clear? Why? Because NP is equal to what? Ne here. So that means atomic number will also be equal to the number of what? Electrons. Likewise, in the periodic table, elements are arranged according to their atomic numbers. Elements are arranged according to their atomic numbers. And of course, if you see an element in the periodic table like this, let's say X, let's say having mass number of A and having what? Atomic number of Z. Here, the A, like I said, is the what? Is the mass number. It's also called the relative atomic mass. It's also called the nucleon number. All right. So in the periodic table, you see an element represented like this. Of course, A here is the mass number or the relative atomic mass or the nucleon number. Of course, the Z here is the what? Is the atomic number of the element in consideration. So do not confuse it for the other. And of course, another important thing to know here about atomic number is that it was first discovered by Sir Henry Gwynne Jeffrey Moseley. This is one name, oh please. This is one person. So it was the person that first discovered what? Atomic numbers. So now we move to relative atomic mass, and we say that relative atomic mass is the number of times the average mass of one atom of the element in consideration, or of the atom in consideration, is heavier than 1/12 the mass of one atom of carbon-12. So it's usually a ratio in relation to what? 1/12 was the mass of one atom of carbon-12. So let's bring that out so that it will be very clear. We say that the relative atomic mass is the number of times the average mass, we underline this average mass, of one atom of that element is heavier than 1/12 the mass of one atom of carbon-12. Right? So please, we are going to revisit this average mass. But note that the relative atomic mass, ROAM, is equals to the sum of the protons plus neutrons in the nucleus of an atom. So to find the atomic mass, or the mass number, you simply add the number of protons to the number of neutrons in the nucleus of of the atom in consideration. So that will give us the relative atomic mass. And of course, we use average mass in the definition of relative atomic mass here. We're using average mass. Why do we use average mass? You may want to ask yourself that question. The only valid reason, it's a JAMB question that can come out, so you have to take note of it. The only valid reason is because that the final mass of an element, the final mass of an element is the average mass, which we are underlining, is the average mass of the isotopes of the element under consideration. So we're using average mass here because the final mass of an element, what will determine the final mass of an element, is the average mass of the isotopes of the element. This now brings a phenomenon to mind called isotopy. We're going to touch on it later on, but here we're going to just give you a brief understanding about what isotopy is, right? And we define isotopy as a phenomenon whereby an element have elements have the same atomic numbers, but have different mass numbers. So element will have the same atomic number, but different mass number. So an element will have the same atomic number, but have different mass number. That phenomenon is what we call isotopy. For example, we have isotopes of carbon, and we have isotope of hydrogen. Hydrogen has 3 isotopes. Hydrogen, you are seeing hydrogen H has 3 isotopes. The first one is hydrogen 1,1, the one we know. This one is called the proton, right? They also have hydrogen 2,1, this one have mass number of 1 and atomic number of 1. They also have the other one that has mass number of 2 and atomic number of of 1, right? This one is called deuterium. Right? So it has mass number of 2, atomic number of 1. They also have the third one that has mass number of 3, atomic number of 1. This one is called the tritium. All right. So Hydrogen has 3 isotopes, and these are the 3 isotopes. But what do we note here in the isotope of hydrogen? In this protium isotope, right? It has no neutron. There's no neutron in the nucleus of this atom. Why this one has 1 neutron, this one has 2 neutrons. How do you calculate the number of neutrons? We say that the number of neutrons is mass number minus atomic number. This will give us the number of of neutrons in the nucleus of an atom. So that means for a hydrogen proton atom, the number of neutrons will be 1 minus 1, which is 0. Because mass number is 1, atomic number is 1. In a deuteron atom, I'm going to have 2 minus 1 as the number of neutrons. I have 1. While in a tritium, I'm going to have 3 minus 1, which is 2. So these are the isotopes of hydrogen. To find the final mass of hydrogen, you must need to find the average mass. You need to find the average mass of the isotopes of the element we are talking about of hydrogen. Now also we look at carbon. Carbon has 3 isotopes. We have the carbon 12. We have the carbon 13, we have the carbon 14, right? This carbon 12 isotope is very stable. It's very stable. This is the stable isotope of carbon. This carbon 14 is very is very unstable. It's unstable, and it is it is radioactive. It is radioactive. And of course, this one also has its uses. So you can have in a JAMB question that which of the following isotopes of carbon is very stable, or which of the following isotopes of carbon is stable, right? Or you can be asked which of the following isotopes of carbon is radioactive. Of course, the radioactive isotope of carbon is carbon 14, and it has its usefulness. It is very, very useful to researchers and scientists. It helps them. It's useful in what we call radiocarbon dating. Radiocarbon dating. In radiocarbon dating, it allows scientists or researchers to peer into the past, to look at how long a particular substance has lived. For example, the number of years a wood has lived, or since when it came into existence. You can peer back into the future to check that. Even you must have seen that, must have heard that a bone was found, and that bone, after using radiocarbon dating, they discovered that it was since 1400 that the bone lived or existed. So it can help us to peer into the future, into the past rather, to know the number of years some particular substances have lived. Of course, you can check the dead bones of animals and of human beings, even wood and pollen, different things, right? So it is very, very useful in radiocarbon dating. That is the usefulness of the radioactive carbon carbon 14. So the decay of carbon 14 is very, very predictable. So that is why it is useful in radiocarbon dating. So of course, those are the isotopes of carbon. Some other elements like chlorine. Chlorine has 2 isotopes. There's chlorine 35. There's chlorine 37. Right. This one the isotopes of chlorine. Also tin. Tin has 22 isotopes. Tin has 22 isotopes. Zinc. Zinc has 21 isotopes. Yes, about 21 isotopes. Then we have neon. Neon has 3 isotopes. Right? Even uranium. You have uranium 235, 234, 238. Right? This uranium, you have uranium 235, uranium 234. We have uranium 238 also. Right? So these are all isotopes of uranium. Of course, zinc, neon, nickel also. Nickel has 14 isotopes. So this one, I'm just saying all these things to make you understand that the final mass of an element is the average mass of the isotopes of that element, because they have different durations. So for you to now get the final mass, you need to get the average mass of the isotopes, right? So another important thing you need to note here is that relative atomic mass is measured in atomic mass units. It is measured in atomic mass units. Relative atomic mass is measured. It is measured in atomic mass units. That is what the AMU, small letter AMU, or it's also measured, or you can call it unified atomic mass units. This one is U, right? So they're the same. They are very, very small units. The atomic mass unit is a very, very small unit. So for you to convert it to grams, you divide by the Avogadro's constant, right? So to convert this atomic mass unit to grams, so you have AMU now, AMU over what? Over Na, Avogadro's constant, it will give us what? To give us grams. All right. So where this Na is equal to what? 6.02 and 10 to the power 23. All right. So that is the Avogadro's what? Constant. So to convert atomic mass units, which is a very small unit, to grams, you divide by what? By the what? Avogadro's constant, Na, which is what? 6.02 times 10 to the power 23. And you have your unit in what? In grams. All right. So having seen this, we are moving over and forging ahead to relative molecular mass. Like I said, this video will not be too long. So in the next video, in the next episode, we'll talk about the mole concept, right? Talk about the mole concept. Of course, so what is relative molecular mass? Relative molecular mass is the number of times the average mass of one molecule of it is heavier than 1/12 the mass of one atom of carbon-12. It's also a ratio in relation to what? The mass of 1/12 the mass of what? Carbon, or one atom of carbon-12. So we can say what? That relative molecular mass is the number of times the average mass of one molecule of it, or that of the substance, either an element or a compound that is in consideration of it, is heavier than 1/12 the mass of one atom of carbon-12. All right. So the relative molecular mass, note that it does not have a unit. And for you to find the relative molecular mass of an atom, what you do, you add what? The relative atomic masses of the constituent what? Atom. Right. So to find the relative molecular mass, you add the relative atomic masses of the constituent of atom. For example, if you have a monoatomic atom like carbon monoxide, and you are told to find the relative molecular mass, you first of all note that what? That the relative atomic mass of carbon is what? Is 12, right? Then the relative atomic mass of, you will be given, if you are not, you will definitely be given, of oxygen O is what? Is 16. Now to find the relative molecular mass, that is RMM now, will be equal to what now? How many atoms of carbon do I have here? One atom of what? Of carbon. One atom of carbon plus how many atoms of oxygen do you have here? Still one atom of oxygen. So, and that will give you what now? 1 plus 1. That is one atom of carbon is what? Is 12 plus one atom of oxygen is what? Is 16. So the relative molecular mass here is what? 12 plus 16, which is 28. So the unit is not gram per mole. The unit is not atomic mass unit. The unit is not grams. It does not have what? A unit. So please take note of that. So for example, let's take another example. Let's say we're trying to find the relative molecular mass of carbon dioxide, like CO2, right? Let's find the relative molecular mass of what? Of CO2, right? See the same thing we did. Relative atomic mass of carbon is still 12. Relative atomic mass of oxygen here is still what? 16. So to find the relative molecular mass, RMM now, because of one atom of what? Of carbon we have, then plus what? How many atoms? We have 2 atoms of what? Of oxygen, right? So that's going to have one atom of carbon is 12 plus 2 atoms. So 2 into one atom of what? Of oxygen. That is what? 16, right? I hope you know why we are bringing 2 here. 2 is coming in because we have 2 what? Atoms of what? Of oxygen. And of course, I know that relative atomic mass of oxygen is 16. So I'm going to have 12 plus 2 times 16 is what? Is 32. So if you add this, you're going to have 44. Is it gram per mole? No, it does not have a unit. So let's do another one that will maybe give us, I want to give you another duration. Let's say, for example, we are told to find the relative molecular mass of calcium hydroxide. That is CaOH2. So to find the relative molecular mass of this is very easy. And relative atomic mass of calcium of Ca is what? Is 40. Relative atomic mass of oxygen, you know, is 16. Relative atomic mass of hydrogen is what? Is 1, right? You know that. So we can forge ahead and solve the question. So to find out of what calcium hydroxide now, because of what now? ROMM now, because of one, is it one atom of what? Of calcium of Ca plus what? We have 2 atoms of what? Of OH. But these 2 atoms of OH contains what? 1 atom of oxygen and 1 atom of what? Of hydrogen, isn't it? So we can say now, say that relative molecular mass is equal to Ca is what? Is 40, then plus what? These 2 will be outside. Then what is the relative atomic mass of oxygen? 16, plus what is the relative atomic mass of hydrogen? 1. We get. So I'm going to have 40 plus 2 into 16 plus 1 is what? Is 17. 17 times 2 is 34. So I'm going to have 40 plus what? 34. And if you add that, I'm going to have what? 74. Is it gram per mole? No. Is it atomic mass unit? No. So relative molecular mass does not have a unit. You see how easy it is. So from the beginning, we talk about atomic numbers, talk about relative atomic masses, talk about the relative molecular mass. So do not confuse them. Atomic number is the number of protons found in the nucleus of an atom. Relative atomic mass is the sum of the protons and the neutrons. And of course, we'll now see how to calculate for the relative molecular mass. The highlight of this is that to convert from atomic mass unit, which is the measurement unit for what? For relative atomic mass, to grams. If you are converting to grams, you divide by the Avogadro's constant, which is what? 6.02 times 10 to the power 23. All right, so this brings us to the end of the class. Please subscribe to this channel. Please click on the red subscribe button on this video. Then give us a like. Give us a like. It helps the YouTube algorithm to make our videos to be seen by other JAMBers like you. And of course, do not forget to share this video to your friends, to your class group, and so on and so forth. And follow our series, because at the end, you'll be happy you did. Thanks for watching. My name remains Owolabi Thank God, aka MC Oglo, and I'll see you in the next class.